My research field is really exciting. It involves looking at natural systems like insects, fish and birds, and trying to understand how their appearance is produced. The physics which goes into the biology and chemistry and general all-round science that makes them appear the way that they appear. Much of the impression we get of the outside world comes in through our eyes. And it comes in the form of color, comes in the form of pattern and intensity. And we just can't help but notice the wonderful array of colors and patterns all around us. And in fact, evolutionary processes have optimized the appearance of many insects and animals and colors so that we see them as most conspicuous. So the question is, how is that achieved? How does nature produce these wonderful, wonderful, strong colors and appearances, and in fact, complicated optical appearances? That's a great question, big question, and if any student is interested in answering that question and trying to gain an understanding as to just what is going on, then this is the field in which to be. This is the exciting area of physics, among many other exciting areas of physics. The student, the school boy or girl who's interested in color and nature could go to no better place than one of the main butterflies that we're studying. And I have a few here. And here is an example of some morpho butterflies. The deep, bright blue ones are morpho butterflies from South and Central America. And the other ones, the two that we have in the middle, they are South African butterflies. And they're just stunning. If I can just take one out for a second and flash it around in the light, you should be able to see this flashing really brightly. Now, we see it as bright, but just imagine what the visual system, the eyes of other butterflies see it as. Our eyes have just evolved to pick up brightness cues, but the butterfly eyes, what we call conspecifics, the same species of butterflies, have evolved to accurately pick up the exact color that's being reflected. So it's bright for us, but it's just amazing. It's like a beacon to other butterflies. This is an example just of one system. Now, when we understand how this color is produced and how the brightness is just so in-your-face bright, then we can start to apply those design ideas to various technologies. We can use them to make new fabric, new surfaces for plates, for designer car body paints, all sorts of things that bright color really sells well, and bright color really helps and assists with. One example of possibly 50,000 different butterfly species. There are 250,000 different beetle species, let alone bird feather colors and bird species and fish species, and all of those need a physics-based understanding. And so my research group needs people, needs students with which to study these amazing things. And so I'd actively and enthusiastically encourage students with an eye in physics, an eye in color, to come and work in this amazing field.